My name's Matt Bullock. I'm one of the technical marketing leaders within the IoT group at Cisco. That is basically a job title for folks that have been a technical marketing engineer for way longer than we typically recommend. I actually was talking to one of the delegates the other day and realized that I've actually been at Cisco now for a quarter century, which really puts things into perspective. I actually started at Cisco as a college intern in what would become the CPOC lab way back in the mid 90s. Didn't get stock options for that. So, feel sorry for me, please. I've been in a lot of places around Cisco, started in SNA switching, I did Ethernet switching, I did ATM enterprise switching, if you can believe that. I've done network management, a couple of years in purgatory, if you will. I've done about 8 years on the ISRs on enterprise routing. And then following that, I came over to the IoT group, and the only regret I have is that I didn't come over earlier because the IoT group is just phenomenal. The things that we get into, as you can imagine, the Internet of Things, when you're actually bringing connections to things pretty much everywhere, that's just a whole lot of really interesting use cases that we get into. And what we're going to talk about today is a little bit of a recap of our portfolio, what we have to offer, how it fits in with the rest of the portfolio from Cisco. You guys, delegates, you know how this works. Feel free to pitch in, ask questions, anything that comes up. We'll try to stay really tight and concise. If we go a little bit long, Stephen will pull out the shepherd's hook and pull me off stage, but we'll try to stay within the time that we have. So starting off here, this is our industrial IoT portfolio. You can see a lot of different products here. We get into a lot of form factors. Funny enough, when I came over to the IoT group, it kind of blew me away a little bit because I'd never seen a DIN rail. I didn't know what that looked like. We have all of these different use cases and all of these different form factors that really just blew my mind. But when you really boil it down, if you're familiar with the routing and switching and wireless products from the enterprise side of Cisco, you already know the majority of this portfolio. It's really pretty straightforward. And if you think about it, that kind of makes sense. I mean, we've got world-class routers and switches and wireless solutions from Cisco. Why would we go reinvent the wheel for industrial spaces, for outdoor spaces, for transportation? Doesn't really make sense. So if you're familiar with the rest of the portfolio, all of the Catalyst series, the Catalyst 8000, the Catalyst 9000 series, you already know most of our switches, most of our routing portfolio in the IoT space. We basically take those designs, soup them up in some ways, generally increase temperature range, remove fans. We build them into mission-specific form factors to fit a lot of different roles and needs. And I'll go through some of that as we go through here. You're familiar with our access points because you know the wireless access points that we have on the enterprise side. And you're even familiar with our embedded products because those are essentially products from the IoT group that are designed to be built into other people's stuff, other people's products. So these are basically printed circuit board form factors for routers and switches and wireless APs. So pretty straightforward there. So you probably already know this portfolio even if you don't realize it. There is a couple of areas, though, that you probably don't know about, and we'll spend a little bit of time in this area today. And a couple of these areas, starting out on the left side there, some really cool stuff that I'm excited about coming over to the IoT group. The first on the left side is Cisco Ultra Reliable Wireless Backhaul, otherwise known as Fluid Mesh. The Fluid Mesh acquisition closed about a year ago, so that's the portfolio that I'll kind of go into and how it compares and contrasts with traditional Wi-Fi and how they really complement one another. And then over on the right side, I was talking to some of the delegates before we got on today about our LoRaWAN solution, long-range wireless sensor technologies, and how we can either customize a sensor environment for you, or we can go in a completely turnkey environment. That's some pretty exciting stuff there. And then finally, last but not least, certainly, management and automation. We're really kind of bridging the gap between IT and OT users in an enterprise or in a user or in a corporation or in a public sector community or city. So that means that we need to support and give you the tools that you need, whether you're an OT organization or an IT organization. So of course, DNA Center and SD-WAN, we've got the same architecture as our enterprise brothers and sisters. So of course we support DNA Center and SD-WAN, but also some additional management tools that are specific to OT users. So let's dig in a little bit more into the Ethernet switching portfolio, and I'm sure you guys will have some questions in here. Just kind of showing you what the broader portfolio of Ethernet switches, at least on the enterprise side and the IoT side from Cisco. Now, if you start on the right side here, we've got data center switches, we've got closet switches, we've got modular switches, blade switches that serve all different kinds of different switching needs all the way down to desktop switches, closet switches. Basically, the common theme there is that they all live in nice, comfy, air-conditioned, we call it carpeted spaces. They can basically go to a cocktail party, have a nice glass of wine, and sit there and sip wine all day and just have a great, kind of laid-back experience. You move over to the left side of the portfolio, that's where you get into the rugged portfolio, the IoT portfolio. It really is the same architecture across the board in most cases. I'll talk about some exceptions to that, but it's really just a continuation of the portfolio into rugged, non-carpeted spaces. Certainly not the place that you'd have a cocktail party. So you see a couple of different form factors here. We've got the cube switches here that are basically DIN rail switches. Those go great into roadside, trackside cabinets, wiring closets, manufacturing floors, those types of areas. We have 19-inch rack mount switches there that go great into utility substations, non-air conditioned spaces, really rugged environments that you can still have a 19-inch rack in. And then the white switches here are generally designed to be even more rugged, even more hardened. They all use M12 connectors, additional shock and vibration protections. So really different form factors that all sort of a common, similar types of technology, but service very different specific use cases. All right, so within that IoT portfolio specifically, I'm not going to talk about most of these. These have been around for a while. The one thing I will point out, though, is that in the industrial space, in the IoT space, we're generally, and most IoT or industrial environments are a few years behind where your typical enterprise user would be. We still see fast Ethernet connections as kind of the bread and butter for a lot of control environments, for a lot of manufacturing environments. We still see a lot of requirements for fast Ethernet. They just don't need anything faster than that. So we still support several switches that still have fast Ethernet downlinks, gigabit Ethernet uplinks. That's still pretty typical. Over the last several years, though, we've been refreshing and enhancing our portfolio with all iOS XE-based switches so that they align with our enterprise switches, and they're all gigabit Ethernet everywhere. So you can certainly see a move towards gigabit Ethernet and now moving in towards 10 gigabit Ethernet. And that's really being driven by some of the new technology, some of the new applications in IoT worlds. So if you think about a connected intersection, a transportation where you have lots of cars coming together, we're trying to do analytics to actually pinpoint and spot vehicles there, to actually spot pedestrians in an intersection using video analytics. You've got a lot of high power, physical power, DC power, as well as high bandwidth HD cameras that all need to connect to that environment. You've got a lot of Wi-Fi 6 and 6E access points, same story. So we need increased power, PoE. We need increased bandwidth for a lot of those use cases that we're seeing in manufacturing and transportation and a lot of different fields. So that's where we get into a new 10 gig switch that basically brings 10 gig and UPoE or 4-pair PoE down into the industrial space, down into the IoT space. So we're really excited about that. It really does turn on a lot of new advanced capabilities, a lot of new advanced analytics capabilities into different use cases that we're seeing evolve in IoT industrial spaces. Okay, so that's.
I had a question there on the portfolio that you all have. You know, we see so many people, and it's great to see the new hotness, right? Mm-hmm. What I'm interested in is, more fiber connectivity to feed remote switches, to feed things that are up on towers or out in parks or, at a distance from the fiber side, because 2.5, 5, and 10 gig over copper is great at small distances, not necessarily at long distances. Yeah. Why aren't you all moving to more of the fiber driven devices? And also, do you have any that are UPoE powered switches as opposed to DC powered switches?
Yeah, good question. So we do not have UPoE powered switches yet. Answering the last one first. Generally, power requirements when you get into this type of arena. The temperature requirements and the power requirements are a little bit different than you would see in a UPoE powered enterprise switch, for example. I'm not saying we'll never get there, but that just hasn't really entered the equation yet. Typically, when you're putting in an Ethernet switch, in our spaces anyway, you've typically got some kind of power available next to it. Not necessarily always going to be the case, but certainly to your point, we do see a predominance really of fiber connectivity for the backhaul between switches, and that's why if you notice here on the IE3300 and really all of our i.e. DIN rail switches that are really designed for that industrial access layer, really. They all have fiber uplinks. Certainly we have some with dual PHYs, dual modes where you can use fiber or copper, but really fiber is kind of the standard, in industrial spaces for that uplink, and then copper for that final last mile connecting to an access point, connecting to a camera, connecting to a PLC to actually drive a manufacturing floor. That tends to be fairly common. That said, we do have essentially aggregation switches. If you look here, the IE4010 and the IE5000, you can think of those as hardened industrial aggregation switches, if you will. Those do come in 12-port fiber, large, dense fiber connections, specifically for that role. That is a little bit of a mixed bag. So if you have an industrial, a non-carpeted, non-air conditioned space at both the aggregation and the access layer, great solution. IE4010 or IE5000 connected to some of the IE DIN rail switches makes a lot of sense. I would say probably what we see a little bit more often though is a traditional enterprise Catalyst 9300, Catalyst 9500, or even 9200 connected to the industrial access switch at the edge. That's especially prevalent, I would say, in manufacturing floors. Where your aggregation layer may be in a centralized closet, an air-conditioned closet, and then your actual access, your actual manufacturing pods your manufacturing cells will be, a little more rugged and out there. Okay.
Cool. Thanks. Yeah. I was thinking more traffic intersections, police and public safety, large distributed areas across cities and small cabinets that are pretty disparate in between the two locations. So.
Yeah. And I would say absolutely the backhaul from those cabinets is very typically fiber. Not always, but certainly that is very typical. Yeah. Yeah. You just honestly, you just don't have the range. You don't have the RF, the EM protection over copper. It just doesn't really work that well. So moving on from switching a little bit, moving to ultra reliable wireless backhaul, aka fluid mesh. We still kind of use those names interchangeably, although the name officially has changed to Cisco ultra reliable wireless backhaul. So much of the industry, so many of our customers are familiar with fluid mesh before the Cisco acquisition. We'll generally answer to both names if you happen to slip and use one or the other. But if it's us talking, we'll almost always say ultra reliable wireless backhaul, or just wireless backhaul, or just simply ultra reliable. Really rolls off the tongue if you shorten it a little bit. So the main goal here is kind of an understanding, and this really blew my mind when I came from an enterprise background to an IoT world. As a matter of fact, one of the interview questions was, well, so what do you think about wireless in industrial spaces? And my background coming from ISRs, from enterprise routing, a little bit of enterprise Wi-Fi was basically, oh, it's great. We use LTE all the time. We have Wi-Fi. Wi-Fi 6 is the next greatest thing. I knew all about that. But really, when you come over to IoT, you really quickly realize that the word wireless means so much more because we are dealing with lots more beyond your 2.4, 5 gigahertz, 6 gigahertz Wi-Fi, your LTE, your 5G. That's of course there. But we have so much more. We have 800, 900 megahertz ISM band. We have 802.15.4 solutions for connected utilities, for meter readers. We have Bluetooth LE. We have LoRaWAN, of course. So we have lots of different technologies that are really designed and purpose-built that's to solve specific needs. Specifically, when we talk about ultra-reliable wireless backhaul, we're really kind of looking to replicate the look and feel of Ethernet, because Ethernet's really kind of the gold standard. What you're saying with, fiber connectivity to an intersection, to a traffic cabinet. That kind of is the gold standard. That's what everyone wants to do. The problem is fiber's expensive, and fiber is fragile. So if you have a fiber run to a connected intersection, or if you're in a port and you have a shipping crane with fiber running to it, that's great. You can get 10 gig. 1 gig, 100 gig, whatever you need over that fiber, but it's still very fragile. It's very, very expensive to run, and it's essentially permanent at that point. You really can't move around. Ultra reliable wireless backhaul is really trying to give you that same look and feel of that fiber backhaul without the need for fiber, without that physical connection. So if I had to define it in just a single statement, it really is wireless fiber-like connectivity that extends a highly reliable network connection where wires can't go. And I'll draw a lot of comparisons with Wi-Fi, traditional 802.11, but that's something we'll clear up in just a little bit. So there is a lot of familiarity, a lot of associations with between ultra-reliable wireless backhaul and Wi-Fi. Essentially, the ultra-reliable wireless backhaul radios use Wi-Fi chipsets. So we use the same frequencies, we use the same scheduling, we use the same on the RF spectrum type of look and feel. But we then kind of break some of the stuff that Wi-Fi uses to make it standardized and multi-vendor and interoperable. And that's so that we can get things like, really long-range, high bandwidth connectivity. It's fairly typical for us to see 15-mile connections at 500 megabits per second. That's not uncommon using the right antennas. Really, the claim to fame is probably fast and accurate roaming with a 0 millisecond handoff at up to 225 miles per hour. This is used on high-speed trains so that you can have zero packet loss. We use it in control networks, control environments where safety is critical, where you have autonomous vehicles that you really need to maintain not just predictable latency, low jitter, but also no packet loss along that path. That's something you really just can't do when roaming in a Wi-Fi environment. That's something we can do in a ultra reliable environment as just part of the natural technology. Real-time latency sensitive traffic, zero loss, of course. Skip over pay as you go because nobody cares about buying this stuff here. We care about technology, right? Lots of different topologies. That's one of the key selling points here is that with ultra reliable wireless backhaul, we can support a point-to-point link if you just need to extend a enterprise connection or a central location connection out to a remote site. No need to run fiber, just run a point-to-point wireless connection and you're done. Same thing if you got lots of places you need to connect, point to multi-point, we'll cover you there. Mixed environments, mixed topologies, mesh topologies, mobility, certainly lots of different topology organizations or arrangements that you can deal with here. And then finally, secure MPLS-based protocol. I'll talk a little bit more about that in a second. So we're basically running MPLS over the whole thing, and that's one of the things that lets us do this really fast reroute and apply quality of service really across the board.
So this is all license free. This is all 2 gig and 5 gig.
This is all 2 gig and 5. Well, actually, it's all 5 gig. Sorry, it's all 5 gig.
Okay. So, yeah, any plans on 60 gigahertz? Any plans to support Telegraph with fluid mesh? Any plans to support 24 gig? Because saying that it's ultra reliable in an unlicensed frequency, I have no words for that. That's you can't. It's a little difficult to swallow. What makes you think that your solution can do what every other solution in the world can't?
Sure. So let me dig into this a little bit, and I think the reason why all of us think that running in an unlicensed spectrum can't do this is because we have so much ingrained history with Wi-Fi, and Wi-Fi is a terrific technology. It really brings connectivity to the masses. It's ubiquitous. It connects anyone, anywhere, no matter what device they bring to the table, no matter what radio they bring to the table, you can get a Wi-Fi connection, and that's fantastic. And that's really where a lot of the hesitation comes from when you're using Wi-Fi in a control environment, because the things that we do in Wi-Fi as an industry are really what make it unreliable for a control network. Now, if you move over to something that kind of breaks that standards-based approach in a good way, so that we're no longer tied to the fact that we have to support multi-vendors. We no longer have to provide client access. We can do things like provide roaming with just a single packet from the client radio to reassociate it with the next access point. Those are things you can't do in Wi-Fi, but you can do that in an ultra reliable wireless backhaul. So really, the only thing that ultra reliable is bringing from Wi-Fi is just the chipsets. So yes, we do run on the same frequency. Yes, we do. Still need to do site surveys. We do still need to make sure that there's not significant congestion, there's not significant interference in that area, but that's true for any technology really. But it is kind of ubiquitous in that you can deploy ultra reliable wireless backhaul anywhere that Wi-Fi is supported. So you don't need that level of licensing, that level of overhead, that level of infrastructure to really go in and support that. So these both kind of fit into that. That middle 5 gigahertz, 6 gigahertz range. Of course, as you go up to LTE and 5G, I think that's kind of where you're going. When you move up into that licensed spectrum, you have pros and cons to each approach, certainly. And I took out those slides intentionally in here just because I knew we wouldn't have time. And of course, we support LTE. We have plans to support 5G, just like all of the other Cisco routers. So that is certainly something that we support. We support LTE for controls. We support LTE in environments. We support private LTE. Those are all certainly on the table. But if you're looking at an alternative that doesn't require all of the overhead and infrastructure, that doesn't require all of the overhead in terms of licensing and deployments, you can do that with a straightforward 5-6 gigahertz spectrum without having to worry about licenses, without having to worry about overhead. And then, of course, we've got the 900 megahertz, the ISM band. We'll talk about that in a minute as we get over to LoRaWAN. But Just for a quick comparison, just to really kind of extensively answer your question, because that does kind of lead through the slides pretty nicely. Why is this different than Wi-Fi? That's sort of the number one question that we get, because we're not going to stop making access points. We're not going to stop making industrial access points. We still have a huge need for those. And those Wi-Fi access points really service end user devices or end devices for the most part. Ultra reliable wireless backhaul doesn't do any of that. We don't service any other radios other than other ultra reliable wireless backhaul. It is a backhaul radio. That's where that point in the name really comes from. So, with Wi-Fi, it's contention-based access. Anybody can send at any time, and then we back off if there's a collision. We just basically have a contention-based access. With ultra reliable, it's all schedule-based. We basically work within the network, within the mesh, to basically decide who's going to transmit, what time slice they're going to get. So we never have to worry about contention within the frequencies if we're all kind of in that same kind of model. We've all got the same radios. We all agree on what this environment's going to look like. Security really is a little bit of a wash in both cases. I mean, certainly Wi-Fi has security across the board today. Very few people deploy Wi-Fi without security. Ultra reliable wireless backhaul, of course, has encryption everywhere, and it is proprietary to its benefit in that it is, something that it's a little bit harder to hack, because we're basically building the radio at both ends of the connections. We can keep everything private, we can keep everything internal, and that's not a bad thing in this situation. Centralized controller is typically, how we would see Wi-Fi deployed. That's great for commonality. That's great for quick deployments. That really kind of hurts you when you're in a fast environment that really needs to reconfigure pretty quickly, like a mobile wireless environment. That's why ultra reliable wireless backhaul uses an MPLS-based overlay. It's MPLS-based. It is MPLS. It's kind of a misnomer to say it's MPLS-based. It's MPLS over the radio. Standard rate adaptation in Wi-Fi. Predictive rate selection will actually track the trends of rates in the network to actually predict what rates we can get. And of course, 0 millisecond initiated handoff. These are basically two complementary technologies here. We do this in ports, a lot of different environments where we'll have a centralized radio connected to rubber tire gantry cranes, to ship to shore cranes. That provides that basically Ethernet connection that looks just like an Ethernet segment to the end user, to the end devices. But there are a few places where we have end user devices, tablets, marshalling yards, where we have to connect to Wi-Fi devices. We just put an access point, a traditional 802.11 access point, next to an ultra reliable device, and you're good to go. So Prodigy, that's sort of the name for that MPLS topology, that MPLS technology, that we basically run. And essentially what we're doing here is just building label switch paths between all devices in the network, all radios really within the network. So every packet that's transmitted has its own priority, has its own quality of service. We get really fast rerouting, just basically matching up new LSPs between radios. You can control what radios have LSPs. You can filter them to really restrict and do some traffic grooming within the network. Physically, and this is probably a better slide for you guys to download, take a look at if you're interested later on. Essentially what we're saying here is that the end devices on either side of the ultra reliable wireless backhaul network know nothing other than just an Ethernet segment. The switches they're connected to will apply a VLAN tag. The radios that those switches are connected to will take that VLAN tag, that VLAN encapsulated packet, apply an MPLS label on top of that, and that's what we use to communicate over the RF spectrum. It's that simple. It really is just straight MPLS on the RF environment. Fluidity, the last feature I'll kind of hit on here with this is basically where we can make a new connection before we break the old connection in a mobile environment, in a high-speed roaming environment. Trains are kind of a primary use case. Dark rides at amusement parks, another good area. Mining vehicles, where you really just can't have any packet loss. We'll actually make a new connection with the radio that you're approaching. Well, before we break the old connection with the radio that we're leaving, and we switch over behind the scenes, we move the LSPs over. So you essentially, the end result is a zero packet loss when you've got two radios on a single moving vehicle like that. The end result is basically, if you go from 802.11 Wi-Fi with controller-based mobility, you're in the 200 millisecond range. If you're using autonomous access points that are basically handling roaming, then you're 600, 500 milliseconds easily with make before break, and this technology, it's essentially 0 milliseconds. You don't lose any packets. Okay. Really quick shot at the radios. Pretty broad portfolio here, just in case you guys have any questions. Most of the deployments we're seeing today are using the radios on the right there, which are external antennas. Pretty broad setup of antennas as well, available from Cisco. Of course, these are Wi-Fi antennas for the most part, so that's not to say that these are the only antennas we support. These are just the ones that you can get from Cisco. So we see a lot of different deployments around the world using different antennas. Monitor lots of different management tools as well. If you're familiar with Fluid Mesh, you're familiar with a lot of these management tools where we actually have management tools that are designed to give you that single pane of glass view in an operations center, giving you real-time status of the network as well as live graphs. Those labels are actually all live graphs that you can customize and change and move around. So a pretty in-depth tool. Really not a lot of time to do a full-on demo here, but if you're interested, we're actually working on a dcloud lab at dcloud.cisco.com. That'll be available later this quarter. You can take a look at that. Last technology that we have here is industrial asset vision, but that's really LoRaWAN at a broader segment. So really LoRaWAN for the masses is how we kind of refer to it. So, if any of you guys aren't familiar with LoRaWAN, it's a technology that's been around for a long time, developed primarily in France and Europe. So we see a lot more adoption in Europe. It uses the industrial, scientific, and medical bands, typically 800, 900 megahertz spectrum around the world, although there is a carve out for 2.4. We don't see a lot of that. Really long distance coverage, really low bandwidth, really low power coverage. So your data rates are going to be really small. 300 bits per second, 5.5 kilobits per second is about the maximum. Really designed for sensor technologies, really getting telemetry from remote sites, from remote devices, but also really long range. I've personally seen 55 miles without really even trying between a LoRaWAN sensor and a gateway. Really long battery life, really long power life. So it's typical that you'll have a LoRaWAN sensor powered by a battery. Certainly 1 to 5 years is not uncommon. 10 years is also not uncommon if you're sending fairly infrequent updates. Really just designed to manage things, to monitor things in remote locations. And LoRaWAN's fantastic for that. We get really customized sensors that really can measure anything and everything from the level of trash in a dumpster to the GPS location of a bull in a field to the door, whether it's open or closed, or the temperature of a vat of baked beans that you're cooking. You've got sensors that really do everything. And each of those sensors have multiple layers of encryption, both to the gateway, to the network server, and the application server. Really, LoRaWAN is designed to be multi-vendor from the ground up so that you can pick and choose the devices, the components that make the most sense in your environment. And that's absolutely something we support at Cisco. We sell gateways, we sell sensors, we'll put it all together for you. That's a lot of work. And really a lot of customers are not looking for something that is that bespoke, that customized for their environment. They just want some basic connectivity. They want some basic telemetry. So that's where industrial asset vision comes into play, with hosting a lot of these capabilities in the cloud, really giving you turnkey solutions that you can just drop in and do monitoring across your industrial spaces, across your enterprise. So if you have a typical manufacturing or food production environment, pretty typical here, where you've got you receive the apples, you store them, you wash them, you sort them, you actually go through baking them and preparing them and making apple pies at the end of the day. Lots of things you need to manage. You need to manage the temperature, you need to manage the location of things, you need to manage the water flow, you need to manage vibration to see if a machine's about ready to die. So you've got lots of different things and components that you want to measure. You just simply use a sensor on each of those, a LoRaWAN sensor. That's typically the way that you would do that. A single LoRaWAN gateway would cover generally an entire campus with the range that you get out of them. And now you've got telemetry. What Industrial Asset Vision does for you, though, is to provide you a complete end-to-end solution. So we give you the sensors, the gateways, the cloud-managed operations dashboard. You've really got everything from one end to the other. So you really don't have to go in and buy a separate component from each vendor. We give you a cell phone app, so you can just scan a barcode on a sensor, associate it with an asset in a location, and you're good to go. Everything's cloud managed. Everything's ready to rock and roll. So
does it support other external LoRa sensors or LoRaWAN sensors? So can I bring the third-party stuff I buy on,
sure,
eBay to the table there?
Absolutely not today, and that is part of the attraction of Industrial Asset Vision. We've got a lot of different sensors. We've got a portfolio of about 12.
Hold on, just to clarify, you said not today?
Not today. We may at some point in the future, but the goal of Industrial Asset Vision is to be turnkey. It is to be simple, easy to deploy. So that's why we narrowed it down to the most common sensors that we see.
Hold on. I mean, just devil's advocate. Wouldn't simple and easy to deploy mean that I could bring my own stuff to the table without having a closed ecosystem? Not to hate too much, but it's like
not at all. I would counter that because we do support that model. We absolutely support that model. You can buy a Cisco LoRaWAN gateway today You can buy a cloud-based application server, network server. As a matter of fact, we partner with Actility, so you can buy that from Cisco. You can buy whatever sensor you want under the planet and on the planet, and you can put all of that together yourself. And that is what most of the industry has done. Most LoRaWAN users have done in the past. You have to put all of that together yourself, and it's complex. A lot of customers, a lot of environments are willing to bite off that complexity to deploy something that is custom, that is tailored for their specific environment. That's not industrial asset vision. That industrial asset vision is to be as turnkey as possible, which is especially why we don't support third-party sensors. Because if you think about it, if we're giving you a dashboard that has well-formatted historical trends for temperature, vibration, water flow, all different sorts of things, we need to understand what that sensor is, what the data is that it's providing, what format it's providing that data in, and how to display it in a meaningful way to the user. That's something you can do in a custom bespoke LoRaWAN deployment, but that's not kind of the easy, approachable type of solution that industrial asset vision is. So I completely agree with you that there is absolutely a need to support third-party systems, to support custom network servers, custom applications, custom APIs. That's kind of a different end of the complexity spectrum from industrial asset vision. Asset vision is really trying to be simple, straightforward as possible. So third-party sensors, absolutely we support them, just not in industrial asset vision. We're really trying to keep things simple and easy to use. Yeah. Okay,
thanks,
so that's go ahead.
Sorry, Matt, could you just go back 2 slides now, please?
Sure, yeah.
Everything I'm seeing there is made of metal, thick metal, and traditionally these metal industrial environments that you're talking about have been terrible for Wi-Fi deployments. Absolutely. What is it that's making this system work in historically abysmal Wi-Fi deployments?
It is.
You have to put a lot of thought into design to make Wi-Fi work well.
Yeah. So short answer is it's the frequency. It's the 800, 900 megahertz low frequency that really just penetrates, in ways that a higher frequency Wi-Fi, typically 5 gigahertz, just can't penetrate. I'm not going to say it's perfect. I mean, certainly if you have a metal container with a sensor inside of it, you're going to get signal loss with LoRaWAN. Just kind of anecdotally, I can tell you in RTP, Research Triangle Park, we have a LoRaWAN gateway up on the roof of one of our buildings, probably about a half-mile away in a parking lot across campus. We have a metal storage shipping container where the workplace resources folks keep salt to salt down the roads when it ices over. We put a sensor in there, closed the metal door, works perfectly fine. So we have non-line of sight, we have a metal enclosure, a metal shipping container, and we have perfect signal coverage. LoRaWAN does a couple of different things, and this is more of the technology than a Cisco solution. One is certainly the frequency. The other is the actual modulation, the actual way that it does modulate, the way that it actually represents data on the RF. It's designed to work in extremely noisy environments. You can actually receive bits, you can actually receive data below the noise floor, which there really just aren't RF technologies that do that. LoRaWAN's fantastic for that.